Hi everyone, welcome back to chemistry. In this last video for chapter 3, we're going to talk about something called formula mass. And this is where we can add up the mass of all of the different atoms in a compound or in the formula of a compound. So the kind of textbook definition is that the formula mass is obtained by adding the masses of each individual atom in the formula of a compound. So looking here at NaCl, you can see that we've got our atomic masses here for Na, sodium, and chlorine. And what we're going to do is we're going to add those two together, and that's going to give us the total formula mass or mass of the chemical formula. And this is always given in AMU, just like we've been looking at our atomic masses on the periodic table in AMU. Those are the units here as well. So if sodium, the mass of a sodium atom is 22.99 AMU, and our chlorine atom is 35.45 AMU, we can add those two together and get the total mass of our sodium chloride compound. Okay, and that's 58.44 AMU. But we got to remember that if an ionic compound has more than one ion, you need to make sure that you multiply by the number of those ions there. So for instance, if you've got the if you're trying to find the formula mass for calcium fluoride, right, CaF2, notice that there are two fluorines there. And you want to make sure that you account for both of those, right? If it was just CaF, you could just add the atomic mass for calcium and the atomic mass for fluorine, and you would get, your answer. But because there are two fluorines, you need to account for those, so you got to multiply. Okay, so here, let's just do this kind of step by step. So for calcium, we've got one calcium ion, and the mass of that is going to be 40.08 AMU, just like we see on the periodic table for calcium. And then we've got two fluorine atoms, each with a mass of 19 AMU. Okay, so we want to multiply that together, and we're going to get 38 AMU over here. Sorry, got a lot of arrows here. Let me get rid of some of those. So 38 AMU once we carry out this multiplication here. And then you just want to total up the mass. Okay, so we've got, 78.08 AMU from adding these two together. Okay, so always ask, how many atoms of each type do I have? Okay, and then multiply that by whatever you see on the periodic table for that atom. And something that's important to note when you calculate the formula mass is, depending on what periodic table you're looking at, the atomic mass that is reported for each different atom or element in the periodic table might be slightly different. It just depends on the periodic table that you're looking at and how they round their numbers. So if your mass kind of differs from someone else's in class, and you're like, hey, wait a minute, why our mass is different? That's just because it's probably because you use different periodic tables, but it's worth double checking your work just in case. All right, so for the first one, copper, Cu, has a atomic mass, and I'm using the periodic table that we have that I handed out in class, so it should be the same as yours. So for copper, what I like to do is I like to write how many I have. In this case, right, there's only one copper because we don't see any number here, so we're just going to assume there's one. Same thing for chlorine, right? We've only got one of them. So I'm just putting the multiplication sign here just so you can kind of see the steps. So at copper on the periodic table is 546 AMU. And chlorine is 35.453 AMU. And so we're going to just add those up together, right? 1 times anything is just that same thing, the same number. So 63.546 plus 35.453. And that should give us a total of 98.999 AMU. All right, magnesium bromide, MgBr2. So we've got one magnesium, so I'm just going to note that. And now we've got 2 bromines here. So we want to make sure that we include those bromines in our calculation. So magnesium is going to contribute 24.305 AMU. And where am I finding that number? Periodic table. Yep, on the periodic table, it's the atomic mass for magnesium. All right, and then for bromine, it's going to be 79.904 AMU. But we've got 2 of them. So let's actually, let's do that calculation here. So 2 times 79.904 is going to give us 159.808 AMU. Now we need to add those 2 together. So, right, we got to add this number and this number. So that plus 24.305 gives us 184.113 AMU. All right, and then Al2O3, we've got 2 aluminums. First off, go ahead and name that compound for me. Yeah, aluminum oxide. All right, so 2 aluminums. That's kind of a funky A there. Fix that. 2 aluminums and 3 oxygens. Okay, so aluminum on the periodic table has an atomic mass of 26.982 AMU, and oxygen has an atomic mass of 15.999 AMU, and that's going to equal 101.964 AMU. All right, so what if you want to calculate the formula mass for ionic compounds that have polyatomic ions in them? You need to make sure, again, that you're accounting for all of the atoms that are in there. Okay, so you want to make sure that you're writing, you're still multiplying by the number of atoms that you have. So for this example here, we've got KNO3. What is the name of that compound? Yeah, that's potassium nitrate. Remember, nitrate is, here I'll highlight it, that's here in yellow. That's one of our polyatomic ions. You don't see the charge on it right now, right? Because it's bonded in an ionic compound. So, right, it should be neutral, and it is. So the NO3 nitrate is NO3 minus. Oh, whoops. NO3, 1 minus. Okay, that's the nitrate ion. And then potassium is 1 plus. Okay, so that 1 minus and that 1 plus cancel out. All right, so that was just kind of a side note there, just kind of review a little bit. But remember, we got to make sure that we're counting all of our atoms. So when we do these, so here you can see we've got our potassium, and we only have 1 of them, right? No number there. So that's just going to be whatever you see on the periodic table for your atomic mass, which is 39.10 AMU. Here we've got 1 nitrogen, okay, and it's going to be 14.01 AMU, just like on how you see it on the periodic table. And then you got to make sure that you account for those 3 oxygens there, okay. So same idea as before, right? We're just taking the number of different atoms that we have, and we're making sure that we multiply the atomic mass for that atom by the number of atoms we have of that particular atom. But sometimes these can look a little weird at first because we get parentheses around our polyatomics when we have more than 1 of them, right? And we talked about that in a previous video. So remember that this 2, and actually let me zoom in here, this 2 here is telling you that you have 2 of whatever is in the parentheses. So you actually have 2 nitrates. So if you were going to look at this, you'd have your Ca2 plus, right? Calcium's going to form a 2 plus charge. And your 2 NO3 1 minuses. And you want to make sure that you account for all of those atoms. Okay? So when you're listing out when you're trying to calculate your formula mass, you got to make sure that you're not writing 2 for oxygens here. We don't have 2 oxygens, right? We have 6 because that 3 and that 2 get multiplied. All right, so that's where this 6 is coming from. It's because we've got those 3 oxygens from our first nitrate and 3 oxygens from our second. Or you could think of it as multiplying 2 by this number here. Math teachers are going to get a little annoyed with me, but you're sort of distributing that 2. You could kind of think of it that way, right? This 2 is kind of getting multiplied by this 3 here and by that imaginary 1 for nitrogen. Okay? All right, so you've got 2 nitrogens as well. 2 nitrogens. So that's where this 2 comes from. And I'll color code that a little bit. All right, hopefully that makes sense, but as always, let me know if you have any questions. So let's try this out. So calculate the formula mass for the following ionic compounds that include polyatomic ions. So we've got calcium. Let's just list out what we have first. We have oxygens and we have hydrogens. And now our job is to figure out, okay, well, how many of each of those do I have? So first off, what is that called there? Yeah, that OH is our hydroxide ion, OH minus. That's our hydroxide polyatomic ion. That's one that you definitely need to memorize, right? It's on your list. We've got 1 calcium, okay, 1 calcium. Notice calcium is not in the parentheses, right? So this 2 does not go over to calcium. That's not what happens. The 2 only goes to what's in the parentheses, right? So we only have 1 calcium. And then how many oxygens do we have? Yeah, 2, because that 2 gets kind of distributed, sort of, for lack of a better term, to that oxygen there, okay? We've also got 2 hydrogens. And you could think of this as just like a side note, right? You've got 1 calcium with a 2+ charge bonding to 2 OH minus ions. And now you can kind of see more easily, oh, okay, that's where I've got those 2 hydrogens coming from, and that's where I've got those 2 oxygens coming from. All right, so for calcium, on the periodic table, our atomic mass is 40.078 AMU. For oxygen, it's 15.999 AMU. And for hydrogen, it's 1.008 AMU. So when we add all of these together, we're going to have 74.092 AMU. And that's the formula mass for calcium hydroxide, our ionic compound with a polyatomic ion. Well, 2 actually. All right, let's check out this one down here. So let's do some color coding here. So in the yellow, what is that polyatomic ion called? Again, one of the ones you got to memorize. Yeah, that one is ammonium. It's our only polyatomic ion that's a cation, NH4+. And then SO4 is what? I almost gave it away. Yeah, it's sulfate. Sulfate, or SO4 2-. All right, so let's go ahead and try this out. In fact, actually, I'd like you to pause the video and try this on your own. All right, so let's do it over here. So I'm just going to start by listing the types of atoms I have. So I've got nitrogens, hydrogens, sulfurs, and oxygens. And now my job is to figure out, okay, well, how many of each? So for nitrogen, how many nitrogens do I have there? Yeah, there's 2 there, right? Remember, there's this 2 outside of that NH4 in parentheses. So 2 nitrogens. How many hydrogens? Yeah, 4. This 4 gets multiplied by this 2 here, okay? So that's going to give us 8 hydrogens. How many sulfurs? Just one, right? This 4, now we don't have any parentheses here, right? So there's just 1 sulfur and 4 oxygens. All right, so now I've listed how many of each type of atom I have. So we're going to have to multiply these by the atomic mass of each of these types of atoms. So for nitrogen, we look at the periodic table and we say, okay, 14.007 AMU. Hydrogen, we saw above. Sulfur is 32.066 AMU. I'm looking at the periodic table. I don't remember these, okay? Don't be impressed. 15.999 for oxygen. All right, and now we got to total all that up. And that's going to give us 132.14 AMU. All right, so that's the formula mass for this compound over here.